the first question is given. Let y is equal to x square minus x over ex. Find and simplify dy over dx. In this paper, we can't use the technology or any notes. Then we have to use the standard formula sheet. Here, the given function is x square minus x over ex. It's a u over v form. That means it's a rational function. Therefore, it is u over v form. To find the derivative of the u over v form, we have to use the quotient rule. From the formula sheet, it is given d u over v dx is v du on dx minus u dv on dx over v square. Now we have to use VCX. Du on dx is 2x minus 1 minus again u. U is x square minus x. dv on dx is the derivative of the ex is ex. Ex whole square. Then if we consider the numerator, ex is a common factor. 2x minus 1 minus x square plus x over e2x. Then if we simplify this, 2x plus x is 3x minus x square minus 1 over ex over e2x is ex. This is the final answer. The part B of the question, let fx is sin x times e2x. There is a product of the two different functions. We are asked to find the f dash of pi on 4. Then we have to use the product rule. U is equal to sin x, v is equal to e2x. Now, what is the product rule? It is u. U means sin x times the derivative of the e2x is 2e2x plus e2x times the derivative of the sin x is cos x. Now we are asked to find the f dash of pi on 4. We have to substitute pi over 4. Sin pi over 4 times 2e, 2 times pi over 4 plus e, 2 times pi over 4 cos pi over 4. Now we know that sin pi over 4 and the cos pi over 4 is 1 over root 2 or root 2 over 2. I can take it out as a common factor. 2e pi over 2 plus e pi over 2. Then this one you can simplify. 3 root 2 e pi over 2 over 2. Okay. The second question is, it is given that we are asked to solve e2x minus 12 is equal to 4ex for x is a real value. Now, this can be written as e2x. What is it? ex whole square. We have to write it ex whole square minus 4ex minus 12 is equal to 0. Now, if we consider this expression, it's a quadratic expression of ex. Okay. Now, I'll take ex is equal to a. Therefore, a square minus 4a minus 12 is equal to 0. Now, if we factorize this one is a minus 6 times a plus 2 is equal to 0. However, a is equal to 6 or a is equal to negative 2, where a is ex is equal to 6 or ex is equal to negative 2. We know that this is not possible. Therefore, x is equal to log e base 6 or x is equal to ln x. Question number 3. It says, sketch the graph of fx is equal to 2 minus 3 over x minus 1 on the axis below, labeling all asymptote with their axial intercepts with their coordinates. Okay. We have to find the asymptote and the axial intercepts. What the asymptotes? Actually, the horizontal asymptote is horizontal asymptote y is equal to 2. Vertical asymptote is x is equal to 1. Now we have to find what the x-intercepts and y-intercept. Y-intercept when x is equal to 0, it is 2 minus 3 over negative 1, it is 5. The vertical asymptote is x is equal to 1 and horizontal asymptote is y is equal to 2. Then we know that the y-intercept is 5, therefore the graph is a negative graph. The left-hand side of the graph is which goes through 5 and this is the asymptote. The right-hand side, we have to find what the x-intercept is. How do you find the x-intercept? When y is equal to 0. 2 minus 3 over x minus 1 is equal to 0. 3 is equal to twice x minus 1. 2x is equal to 5. X is equal to 5 over 2 or 2 and a half. Then this is the asymptote. The graph is like this. Okay. This is, we have to write down what the x-intercept, y-intercept is 0, 5. X-intercept is 5 over 2 and 0. Now find values of x for which fx is less than or equal to 1. Less than or equal to 1 means like this. When y is equal to 1, what is the x value? We have to equate 2 minus 3 over x minus 1 to 1. 2 is equal to 1 plus 3 over x minus 1. X minus 1 is 3. X is equal to 4. When x is equal to 4, fx is equal to 1. Therefore, what is the fx is less than or equal to 1 means x should be greater than 1 but less than or equal to 4. Let's go to the question number 4. It is the graph of y is equal to x plus 1 over x is shown over part of its domain. Here, this is the y is equal to x plus 1 over x. Use two trapeziums of equal width to approximate the area between the curve, the x-axis and the x is equal to 1 and x is equal to 3. We are asked to use the two trapezium to calculate the area between x is equal to 1 to 3 and the curve and the x-axis. Then I have to divide into two trapeziums with equal width. That means if I draw the line when x is equal to 1, x is equal to 2 and x is equal to 3, there are two trapeziums. What are these values? When x is equal to 1, what is the y value? Y value is 2. When x is equal to 2, what is the y value? 2. 2 plus 1 over 2 is 5 over 2. When x is equal to 3, what is the y value? 10 over 3. Now, we are asked to use these two trapeziums. We know the area of a trapezium is equal to half times a plus b times h. What is a and b? A and B are the length of the two parallel sides and h is the perpendicular distance in between A and B. Therefore, the area, the total area is the area of the first trapezium. What is it? A is 2, 2 plus 5 over 2 times 1 plus the second trapezium is half times A is 5 over 2 plus 10 over 3. I can take half as a common factor. 2 plus 5 over 2 plus again 5 over 2 plus 10 over 3. We have to simplify this. Half 2 plus 5 over 2 plus 5 over 2 is 5. 10 over 3. If we simplify this one, half 7 plus 10 over 3. This is half times 21 plus 10 over 3. What is it? 31 over 6. This is the required answer. Let's go to the question number 5. It is an anti-differentiation question. Then here, evaluate 0 to pi on 3 sin x dx. That means we know that 0 to pi on 3 sin x. What is the anti-differentiation of the sin x is? We know that it is negative cos x. 0 to pi on 3. We have to sub in the upper limit, negative cos pi on 3 minus cos 0. That means negative half plus 1. The answer is half. The part B. Hence, so otherwise, find all values of k such that 0 to pi on 3 sin x dx is equal to k to pi on 2 cos x dx, where k is in between negative 3 pi to positive 2 pi. We know that the left hand side of the given expression is equal to half. Half is equal to k to pi on 2 cos x dx. Half is equal to, what is the antiderivative of the cos x is sin x. Sin x k to pi on 2 half sin pi on 2 minus sin k. We know that sin pi on 2 is 1. Therefore, sin k is equal to 1 minus half. It is half. Sin k is equal to half. What is the base angle? Sin k is equal to half means k is equal to pi over 6. But sin is positive in the first quadrant and the second quadrant. Therefore, the other angle is pi on 6, so pi minus pi over 6. It is pi on 6, so 5 pi on 6. However, the period of the function is 2 pi. Therefore, if we want to get more solutions to the right hand side, we have to add the period, or to the left hand side, we have to subtract the period. We are asked to find the values of k in between negative 3 pi to positive 2 pi. Therefore, we can't add the 2 pi. We have to subtract pi on 6 minus 2 pi. 5 pi on 6 minus 2 pi. Pi on 6, 5 pi on 6. 11 pi on 6 or negative 7 pi on 6 or pi on 6 or 5 pi on 6. These are the values of k which satisfy the given condition. Question number 6. Let p hat be the random variable that represent the sample proportion of households in a given suburb that have solar panels installed. From a sample randomly selected household in a given suburb, an approximate 95% confidence interval for the proportion P of household having solar panels installed was determined to be 0.04 to 0.16. Actually, the 95% confidence interval is 0.04 to 0.16. Find the value of p hat that was used to obtain this approximate 95% confidence interval. Okay, we know that the p hat is our actual mean. Therefore, if we consider the distribution, p hat is here, the 95% confidence interval, the right hand side the confidence interval is 0.16. The left hand side is 0.04. Therefore, p hat is in the middle. P hat is equal to 0.04 plus 0.16 over 2. This is 0.20 divided by 2, 0.1. Okay, now let's go to the part B. Use Z is equal to 2, approximate 95 confidence interval. Find the size of the sample from which this 95% confidence interval was obtained. We know that from the formula sheet, the confidence interval is given by p hat, this one, p hat minus z is this one, or p hat plus. This is the left hand side, this is the left and right. We are asked to find the n value. We have to pick up either left or the right value. I'll pick up the left hand side. Therefore, 0.04 is equal to p hat is, we know that 0.1. The z value is 2. 0.1 times 0.9 over n. If we simplify this one twice, 0.1 times 0.9 over n is equal to 0.1 minus 0.04. Twice 0.1 times 0.9 over n is 0.06. Therefore, 0.09 over n is 0.03. 0.09 is equal to n times 0.03 whole square. N is equal to 100. The sample size is 100. If we go to the part C, a larger sample of the household is selected with the sample size 4 times the original sample. The sample proportion of the households having solar panels installed is found to be the same. By what factor will the increase the sample size affect the width of the confidence interval? Width of the confidence interval can be written as 2z times p hat 1 minus p hat over n. However, it says the sample size is 4 times the earlier one. Therefore, 2z p hat 1 minus p hat over 4n. 4 can be taken out. 2z over 2 p hat 1 minus p hat over n. However, the original width of the confidence interval is dilated by factor of half. What is the answer? Factor of half. This is the answer. Question number 7. Consider f. F is a function from negative infinity to 1 to r. Fx is given by x square minus 2x. Part of the graph y is equal to fx is shown below. This is the graph. The first question, the part A, we are asked to state the range. What is the lowest value? Lowest value of the y is -1 to infinity. Okay. The part B, sketch the graph of the inverse function y is equal to f inverse x. On the axis above, label any endpoints and axial intercepts with their coordinates. We are asked to sketch the inverse function. Inverse function is the reflection through y is equal to x line. Okay, x is equal to 1, y is equal to -1 goes to x is equal to -1 and y is equal to +1. Then the other one, x is equal to -1 and y is equal to -3. X is equal to 3 and y is equal to -1. 0, 0 remains as it is. Now we have to draw the graph. It is like this. We are asked to label the endpoints. The starting point is -1, -1 and 0, 0 axial intercepts. And this one is 3 and -1. Okay. Now the given function is y is equal to x square minus 2x. We have to interchange x and y. X is equal to y square minus 2y. Now we have to make y the subject. To make y the subject, I'll use the method of complete the square. Y square minus 2y plus 1 square minus 1 square. These first three terms can be written as y minus 1 whole square minus 1x. Y minus 1 square is equal to x plus 1. Y minus 1 is plus or minus the square root of x plus 1. Y is equal to 1 plus or minus square root of x plus 1. Now we have to think about the inverse function is a negative square root function. Therefore, inverse is, if inverse x is 1 minus x plus the square root of x plus 1. 1 minus square root of x plus 1. The part D is calculate the area of the region enclosed by f inverse and y is equal to -x. We are asked to find the region in between f inverse and y is equal to -x. If I draw the y is equal to -x line, it is like this. Then we are asked to find this region and this region. Both are same because it's a symmetric graph. If I find one of these regions, I'll take this one as A1 multiplied by 2. It is the required region. A1 is equal to 0 to 1 -x minus x square minus 2x. 0 to 1 -x minus x square plus 2x dx. 0 to 1 x minus x square dx. 0 to 1 x dx minus 0 to 1 x square dx. X square on 2, 0 to 1 minus x3 on 3, 0 to 1. Half minus 1/3. It is 1 over 6. Therefore, the total area 2 times 1 over 6. It is 1 over 3. Let's go to question number 8. Suppose that given time t in minutes at a customer service desk has probability density function given by ft is equal to kt times 16 minus t square in between 0 to 4. The other one is 0, as where it is 0. Where k is a real value. Show that k is equal to 1 over 64. We know that the total probability of the probability density function is equal to 1. Therefore, 0 to 4 ft dt is equal to 1. 0 to 4 ft is k times t. 16 minus t square dt is equal to 1. K is a constant. Therefore, 0 to 4 t 16 minus t square dt is equal to 1. K 0 to 4 16 t dt. Since k is a constant, I can take it out. T to the power of 3 dt is equal to 1. Now, k, this is 16 t square on 2, 0 to 4 minus t4 on 4, 0 to 4 is equal to 1. Now k 16, when we substitute the upper limit, 16 over 2 minus 16 times 16 over 4 is equal to 1. Now k, if I take 16 times 16 out, half minus 1/4 is equal to 1. K times 16 times 16 times 1/4 is equal to 1. K is equal to 4 divided by 16 times 16 means 1 over 64. The second part of the question, the part B, we are asked to find E of t. E of t is the expected value of the function. We know the expected value can be written as 0 to 4 t times ft dt. 0 to 4 t times k. Ft is, we know that 16 minus t square, kt 0, 16 minus t square dt. K can be taken out, 0 to 4 t square, 16 minus t square dt. This is E of t. K. Now this can be written as 16 times 0 to 4 t square dt minus 0 to 4 t to the power of 4 dt. Now k, this is 16, this is t3 over 3, 0 to 4 minus this is t5 over 5, 0 to 4. We know that k is 1 over 64. 16 times 4 to the power of 3 is 16 times 4 over 3 minus 4 to the power of 5 is 16 times 4 over 5, 1 over 64. Then if I take 16 times 4 as a common factor, 1 over 3 minus 1 over 5. We know that 16 times 4 and 64 can be cancelled. This is 16 times 2 over 15. The answer is 32 over 15. The part C of the question, what is the probability that a person has to queue for more than 2 minutes given that they have already queued for 1 minute? Actually, we are asked to find the probability t is greater than 2 given that t is greater than or equal to 1. According to the conditional probability, this can be written as the probability t is greater than 2 intersection t is greater than or equal to 1 divided by the probability t is greater than or equal to 1. Now, this is the probability t is greater than 2 intersection t is greater than or equal to 1. Greater than or equal to 1 means 1 to 4 ft dt. We will check what this common region is. Greater than or equal to 1 is here. Greater than 2 is here. This is 2 to 4 ft dt divided by 1 to 4 ft dt. Now we know what the ft is. K times 2 to 4 t times 16 minus t square dt divided by k times 1 to 4t times 16 minus t square dt. We can cancel k. This can be written as 2 to 4 16t minus t to the power of 3 dt divided by 1 to 4 16t minus t to the power of 3 dt. 16 can be taken out. 2 to 4 t dt minus 2 to 4 t3 dt divided by 16 times t dt 1 to 4 minus 1 to 4 t3 dt. 16, this is t square on 2 to 4 minus this is t4 on 4 2 to 4 divided by 16, this is t square on 2 1 to 4 t4 on 4 1 to 4. If we substitute 16 minus 4 divided by 2 minus 256 minus 16 over 4 divided by 16 times 16 minus 1 over 2 minus 256 minus 1 over 4. Here this is 16 times 12 over 2 minus 240 over 4 divided by 16 times 15 over 2 255 over 4. This is 8 times 12 minus 60 divided by 8 times 15 minus 255 over 4. This can be written as 36 times 4 over 32 times 15 minus 255. It is 36 times 4 divided by 225. The answer is 144 over 225. Question number 9. The shape of the two walking tracks are shown below. The track 1 is this way and the track 2 is this way. The question is track 1 described by the function fx is equal to a minus x times x minus 2 square. Track 2 is defined by the gx 12x plus bx square. The units of the length is kilometers. Given that f of 0 is 12 and g of 1 is 9, verify that a is 12 and b is negative 3. We know that f of x is given a minus x times x minus 2 square. However, when x is equal to 0, f of 0 is a. What is a? A. F of 0 is given, it is 12, therefore a is 12. Similarly, g of 1 is equal to 9. That means 12 times 1 plus b is equal to 9. b is equal to negative 3. Part B of the question, verify that fx and gx both have a turning point at P. Give the coordinates of the point P. Now we know that fx is 12 minus x times x minus 2 square. 12 minus x, x square minus 4x plus 4 12 minus x to the power of 3 plus 4x square minus 4x. What is f dash x is negative 3x square plus 8x minus 4. At the turning point, negative 3x square plus 8x minus 4 is equal to 0. 3x square minus 8x plus 4 is equal to 0. This is 3x square minus 6x minus 2x plus 4 is equal to 0. We can split the middle term. If I take 3x out, x minus 2. If I take negative 2 out, x minus 2 is equal to 0. 3x minus 2 is equal to 0, or x minus 2 is equal to 0. X is equal to 2 over 3, or x is equal to 2. Then the gx. The gx can be written as 12x minus 3x square. B is 3. G dash x is 12 minus 6x. At the turning point, 12 minus 6x is equal to 0. Therefore, x is equal to 2. However, now we know that x is equal to 2. Both of them had the turning point. X is equal to 2. What is g of 2? 12 times 2 minus 3 times 2 square. 24 minus 12. The turning point is 2 and 24. This is the coordinate of the turning point. Part C. A theme park is planned whose boundaries will form a triangle OAB, where O is the origin, A is at K0, B is at K and GK as shown below, where K is in between 0 to 4. Find the maximum possible area of the theme park in square kilometers. Yeah, now we know that it is given that this is K0, this is 0, 0, this one is K and GK. Then the area of the triangle OAB triangle is half times base times height. Half times what is base? Base is k. The height is g of k. K over 2 times g of k is 12k minus 3k square. Half times 12k square minus 3k to the power of 3. The maximum area, we have to find the derivative of the area. I'll take A is equal to half times 12k squares minus 3k to the power of 3. Therefore, dA on dk can be written as half 24k minus 9k square. Now, at the maximum, dA on dk is equal to 0. That means 24k minus 9k square is equal to 0. K 3k if I take 8 minus 3k is equal to 0. Therefore, k is equal to 0 or k is equal to 8 over 3. K belongs to 0 to 4. Therefore, k is not equal to 0. You have to take k is equal to 8 over 3. Now the area A is equal to half times k times 12k minus 3k square. Half times 8 over 3, 12 times 8 over 3, minus 3 times 64 over 9. 4 over 3 4 times 8 minus 64 over 3 4 over 3 32 minus 64 over 3 4 over 3 96 minus 64 over 3 4 over 9 times 32 this 128 over 9 square kilometers. This is the final answer.